ready to get started, and we can move on to the first slide. So welcome everyone once again to the webinar. I am Miles Harrison, the company principal Praktikai, and I'm joined by some members of my team here, and Jan Scholz, who is our principal data scientist, is going to be taking us through this webinar today on agentic coding and how agents and AI are revolutionizing software development, and also how we have used agentic coding practices internally in Praktikai to deliver a project that we delivered. So those are just joining, please make sure you're muted. And with that, I will hand things over to Jan to introduce things and get us going. Take it away, Jan.
All right, thank you for the kind introduction, Miles. And I will talk about agentic coding. I hope many of you, I don't know where your fields are, if you're just starting on your journey as a software developer or data scientist. So this talk will kind of go over some overarching approach and maybe philosophy, and with a few practical examples. Obviously, with agentic coding being a new field, and new products and new features coming out every minute. The field is very evolving, and this talk, which is based on 2 blog posts I wrote a couple of months back, might already be outdated here and there. So if you have any comments, feel free to put them in our comment section, or raise them in the discussions as well. Very happy to hear some feedback on it. If I talk, just one more thing, if I talk about LLM in this talk, I mean LLMs, I mean ChatGPT, I mean any kind of agentic coding or AI-assisted coding tool. So don't be thrown off. I'll just call it LLM for short, because that's what's underlying most of those tools. All right, let's start with the agenda. So we're going to talk about the problems of traditional code development. So anyone who has been coding for a couple of years will be very familiar with those, especially those who started coding before the advent of AI, and then how AI is addressing some of those issues, and then how we at Praktikai see the use AI-based coding assistance, and then we'll maybe, if you have time, look at a concrete example. And then we'll have some questions and time for questions and answers. So first of all, I called it the nightmare of traditional software development. I don't know. I assume a lot of young people are here, so maybe you're not very familiar with it. So bear with me when I try to kind of explain that. But the core idea is in the olden days before LLMs, it was very hard to make time for what you really wanted to work on, the core algorithm, the core business logic, as it's called, because there's all these peripheral tasks you would spend often way more time than you wanted to on, right? So what are those peripheral tasks? They are to do, with versioning and packaging and publishing a package. So Python programmers here on the call might be very familiar with downloading packages from PyPy. So how do you create a package there? Testing. So you would, spend time trying to understand a testing framework and how to apply that to your software, and then documentation. And there are many other tasks like that. But all these tasks have in common is that they get in the way for you to actually develop whatever cool algorithm you have in mind, right? Or a cool product you want to build. So you have to, on top of that, you have to learn all these other things. And that's what I call the nightmare of traditional software development, that this, it's like these tasks are like vampires sucking your time away, right? Then the other core issue with software development was the fragmented tech stack. Again, people who have been longer in the industry are very familiar with how many languages and frameworks there are, right? So if you just think back at scripting languages, programming languages, configuration languages, like YAML and TOML and so on, and database languages like SQL, and all these different subtly different languages you had to learn in the past to kind of get to do these things, right? So to configure a framework, although you were programming maybe in Python or in C, to do these other things, you had to learn other languages as well, right? Or if you wanted to interact with databases, then you had to learn SQL. So another kind of stumbling block here. Another time suck is poor documentation, right? So luckily we live in a world where there's a lot of people who donate their time to produce awesome software and give it away for free as open source, right? We can leverage that, but often that's very hard for small maintainer teams to also do the documentation. And even if you go, anyone who has tried to find answers in the past, even for Google Cloud, their documentation is also lacking in some areas, right? So it can be sometimes very hard to figure out how to use things due to the documentation. So you resort to going to online communities to figure out issues there, and that takes time, right, to search and find those issues. And then finally, another nightmare is the rapidly evolving ecosystem. So again, for people who have been in the industry for a couple of years at least, and especially for those who have been here for a decade or so, they have seen frameworks come and go, right? For data scientists, maybe TensorFlow was the thing back in the day, and now nobody's really talking about it anymore. Same for front-end frameworks. It used to be Angular. I think most people don't even remember that name anymore. So just keeping up with what's coming down the pipeline can be tough and can lead to burnout. So these are the sort of the things that we think we should focus our LLM efforts on rather than the core logic development. Move on. So what can AI-assisted coding actually do? Or why does it help, right? So let's not think about vibe coding yet. So LLMs and coding assistants, why they're so good? Because they make everything accessible via human language, right? So I can actually, without maybe knowing the details of a programming language, I can instruct it in human language, write me this function that does these things or solve this problem in code. So previously you had to learn the language to do it, right? So you would spend a week or two to ramp up on a new language and read through blog posts or buy one of those very thick O'Reilly books and try to study it. Now you can just use your own language to get to the same point. Another thing is translating between programming languages. So maybe you're a data scientist who is mostly familiar with Python, let's say. Now you're being asked to query a database with SQL. So you wrote some Python code to query data from a local CSV file or something like that. Now you can just ask an LLM, okay, translate that piece of code to a SQL statement. That can be done very seamlessly. The same on the previous slide, we talked about the rapidly evolving ecosystem. And if your fish is changing from Python to Rust or something like that, or if you are switching APIs or something like that, that translation aspect is now very easy and often trivial. Another advantage of LLMs is that they filter out the noise. Again, people who have done this in the past before AI know how much noise is out there. If you want to solve a particular problem, you have to scroll and read through dozens of Stack Overflow discussions, GitHub issue discussions, blogs, and so on, to find that one person who had the same issue that you had, and then hope that they actually went back and let other people know about the solution to that. Now, LLMs either have been trained on that data already, or they're using tools to search for you, but then they also summarize things and get rid of all that noise, right? So all these, in a discussion, all these answers that are not relevant to your problem, you don't even get to see them. You don't have to scroll past them. So great benefit here. Great time saver. A third one is LLMs don't chill. Again, pre-AI, people spend a lot of time on Stack Overflow and similar forums, and you would always invariably have answers to your question, to your genuine question, which were like, oh, this is actually not a challenge, this is not a problem, just live with it, or you should use this completely different thing at great cost, or other things, right? So those answers would not really help you solve your issues. It was just people who would propagate their own kind of worldview that everything has to be solved in Haskell or whatever, but that wouldn't help you. So LMs are actually, to this point, will wait, a couple of years. It might change, but at this point, I think they don't chill, they don't have an agenda, they don't try to sell you on a particular framework. And so if you give them your requirements, what you want to use, let's say you want to use Python, you want to use a popular and easy to maintain frameworks, it will just give you that. It will not try to convince you to use an overly complicated framework because that's supposed to be faster, something like that. And then finally, LLMs help iterate and pivot. So depending how you're using that, if you copy or paste your error message into ChatGPT or use AI-assisted coding tools like OpenCode, Claude, and so on, they will read your error messages and they will often be able to fix the issue immediately. They can explain that issue to you. And then also, now it's very easy to pivot, right? So pivoting, let's say as a data scientist, you wrote some code for the flow, and now you decided you want to go back to PyTorch, different framework. You can ask the LM to refactor that, keep everything the same, but just use a different API or framework. So that's for us 4 main benefits of LLM. So now we're going to switch track a little bit and talk about our kind of approach here. So again, there's a big kind of confusion sometimes in the industry about vibe coding. So we at Praktikai think that vibe coding is not a great thing to do because it actually, by definition, absolves you from understanding the problem that you're trying to solve, right? So you're just telling the LLM some loosely defined problem and then say, go away and solve this issue somehow. I'm not interested in reflecting on if this is the right approach. I'm not interested in learning what technology was used and how this was solved, right? So that's the vibe coding bit. For your own career safety, I guess, you want to be still an active participant. You want to continue to learn. You want to grow in that experience. And so our suggestion is to be very conscious about continuing to learn and build out those skills rather than having those skills fall by the wayside and getting sort of less and less involved in the process through vibe coding. So basically, what we are looking here at is an approach that's now 30 years old. So Fred Brooks, in his book Mythical Man Month, he came up with a phrase that you should, or he observed basically that doing software development projects, it would always end up that the first set of code would be thrown away, right? Whether that was a voluntary decision or involuntary, it would just happen that way, right? So the first code base that was built and ran into a lot of problems later on, and then had to be substantially refactored or even thrown out and done again. So Fred Brooks had that idea that, well, if that happens anyway, then let's plan to throw the first version of the code away. And that's his prototype, throwaway prototype approach, right? To actively plan for doing this throwing away piece. Obviously, that's often, depending where you work, that's not a easy thing to get your managers or superiors on board with, right? So if you go ahead and you say, oh, I'm going to just build some code here, but I know I'm going to throw it away and I'm going to do it again, the alarm bells might go off if you work in a big enterprise, and they're going to tell you, well, that would be waste, right? We are all about saving costs here. Don't just write code on our dime and throw it away. Or they might be afraid about the impact on the timeline. We don't have the time to rewrite the code, right? Just write it right once from the get-go, and don't throw anything away, right? So we don't have time to do these things. But what Fred Brooks and many others realized is that the time you save or the cost you save in the beginning, it will bite you in the end, right? So if you stick too long with an outdated code base, it will slow you down in the long run, and you will accumulate technical debt, which you spend time and resources on later to resolve it. And in the worst case, it might actually restrict how you can enhance your product later on, right? It just might not be possible that your code base can adapt to features because it wasn't built the right way the first time. Hopefully that makes sense. So what we are proposing here is to have 4 phases of throwaway prototyping. So the first phase is you start in your comfort zone, right? So, and with your own biases. You start, let's say, as an example, and I'll demonstrate one later on if we have time. You are a back-end developer who's not very familiar with front-end development and JavaScript and so on. Where would you start if you had a project like a voice assistant, right? So like, okay, as a backend developer, I will start on the backend side. I will solve this issue on the backend. And then, because I don't know anything about front ends, I'll, in my head, when I plan, I'll say the front end doesn't really have to do anything. I'll do everything on the backend through APIs and all the text, speech to text and text to speech, and the conversation management will just go through fast API and endpoints and all these things, right? So that's my bias, right? So it's like, okay, if I use it I'm going to solve this issue this way. So that's your first prototype. You write the code, and it might work. You might start with you might run into an issue because you made assumptions that don't turn out to be good decisions. So let's say you build this voice assistant with real-time speech processing, right? So you're sending every 30 milliseconds of voice into your backend to make it real time, right? But then that comes with a lot of complexity and potential issues because what happens if you miss any kind of voice data, or it arrives not in order, or whatever it is, right? So when you realize that, okay, it doesn't work, you move on to, you throw away the code, right? you move to phase 2, the comfort zone, but you're trying to overcome your biases. So this is the traditional prototype approach, right? You build something, and only by building it and looking at it and playing with it, you learn something. And so now in this example, you've learned that this real-time audio processing is it's overly complicated and it's not actually necessary, right? So now you move to phase 2. You start again in your comfort zone. You might focus on the backend, but this time you're going to leverage some pre-existing APIs to do the speech to text, right? So now you're going from this highly real-time communication to a more asynchronous approach. And it turns out that actually solves your problem, right? So you have a more robust version now. It's not as brittle and it's not as complicated. And bravo, you learned something. This approach is feasible. It's manageable. You like it, right? But you build maybe a little bit of a front end around it, and you realize you're not a great front end developer, right? So at that point, you move to phase 3. So that's your stretch zone. Again, you start from scratch, or you throw away large parts of your code base. In this case, maybe the front end code base, where you realize you're not actually a good front end developer. And to get out of your comfort zone, you use AI. You really use it for that purpose, right? So through the whole process, you're still leveraging your skills, you're still learning. And now you got to the point where you cannot actually do it by yourself. So here you use your assistant and ask the AI to build you a front end, right? So, and maybe that front end is like built one shot, it looks great, as always, as those things look usually. And you're really impressed, right? But then you look at the front end code and you're like, oh my God, what happened here, right? It's a mess. By repeatedly asking the AI, add this button and add this functionality and put this image here a little bit higher or whatever, it just accumulated all this code and there's not a real structure to it, right? So at that point, you discard prototype 3 and you move to the final phase, phase 4, where you're in your stretch zone, right? You're using AI to help you develop something that is out of your comfort zone, let's say the front end piece. And but you've learned something. You looked at the process of how the AI built the front end. You looked at the code, and now you're way more informed in what is possible and what kind of pitfalls you want to avoid. And so you're overcoming your aim in phase 4 is now to overcome the AI bias, right? So using AI to overcome to get out of your comfort zone and get help on the front-end development side, but you're now much better prepared to instruct the AI to build the code the way you want it to build, right? So you've learned something, maybe adapter patterns or whatever JavaScript kind of pieces or React framework kind of terminology, and now you can instruct the AI to do it this way, and you end up with a better product. So a lot of words, but a very simple concept to basically be prepared to let go of existing code and do it again. Why can we actually do it now much better than previously? Because each of these phases can be 1 to 3 days long. So they're very quick, and you're not the management's criticism that this might take time or is a waste is actually not true anymore, because with AI assistance, you can blow through those phases more quickly. Okay, so how does this actually look? As an example, and I can, during question and answers, I can go through that in a little bit more detail if there's anything in particular, but let's look at this voice assistant. So the idea here for this project was to deliver an investor-ready prototype in just 4 weeks. And we chose the approach on the previous slide to get there very quickly with a very small team. We're able to build a robust application with all the desired features and also deploy it on the cloud, right? Let's see. Just give me a second to. So hopefully everybody can see the audio bot. Yep. So the idea was here to have a conversational agent that can, which is a prototype at this point, but it might look like a sort of Alexa device or something like that in the future, and then understand how we can build all the infrastructure around it. We can click on the Start Listen button, and I'm not going to do this right now. But the throwaway prototype kind of approach here was to first build the backend infrastructure, right? So each of these functionalities here calls API endpoint, right? And so you can actually build the backend without the front end if you wanted to, right? So that was the phase 1 and 2, and then we used AI-assisted coding to build the front end. And because we had the back end narrowed down, the routing and the endpoints, they could actually function as a design specification for the front end as well. One of the first things we did is basically, as we are developing the voice input, just to test that data is flowing correctly, we built a function here to send a chat message to the backend directly. So that helps us with testing, right? The next thing we implemented then was user profile management. So later on, a voice assistant might be specific to you as ChatGPT is, right? Through authentication, but just for testing, we created a database of users and their preferences. So in this case, let's say we added some knowledge around what we know about the user. So that could be derived from the from previous chat messages or whatever. So we can modify that system prompt. Again, because everything is done through APIs, it becomes very Lego-like, right? We can put it all together. So there's somewhere is a place that saves the system prompt, and there's a place where we save the user information, and we can kind of modify that on the fly through our front end. Yeah, so that's one way to build an application like this.
All right, so just to wrap up what Jan was saying about this approach with using these new tools, what's the so what, as we say in the business? Obviously, we're talking about doing this with a very agile team, a very small team, to build quickly and rapidly. And as Jan said, this type of throwaway prototyping, leveraging these new tools for accelerated development, can be a tough sell inside of an enterprise. But if you articulate it the right way, and if you do it properly, there's obvious value to be had. It's just a question of talking about it the right way to get over some of that discomfort and what I would say are some of our biases about how to do work, and this kind of linear way of thinking as opposed to this iterative way of thinking, to iteratively build product and have it build stage by stage. So one of the obvious benefits is you are able to deliver a lot more with a lot less in a shorter time. So in large enterprises, I know that what PMs care about is the project management triangle. And we have a very small team, but as Jan said, we were able to deliver this functional prototype and deploy it in a matter of just 4 short weeks. And I think internally we were discussing it and saying that if you were doing this in a larger organization or not using these tools or not using this approach, that would probably have been, a quarter or maybe even more, right? So obvious value proposition here is just leveraging these tools and then using this approach together to be able to build product faster and not get hung up in the details and not get bogged down by a lot of the stuff Jan talked about that is part of the nightmare of traditional software development. And because time is money, as I am very much aware of, and people's time is expensive, this is going to result in reduced costs, right? You're building more product quicker. You're using less person hours to do that with the assistance of these tools, and so that's going to translate to significantly reduced costs. I will caveat that by saying, and just being realistic, that you also do have a new additional cost that offsets some of that cost reduction, which is you need to keep an eye on your utility bill, because now with a lot of these models, you're being charged by the usage, and you have a new kind of tech cost around how much you're using these tools to do the development. But given the way these things are priced, if you look at the cost of a development team and their time, that amount, if you're doing this type of approach effectively, is going to be far less than the amount of significant people hours you would put into doing the same type of work. Another thing you can do is develop better internal tools. There's some tools that people sell. There's vendor lock-in, and there's a lot of a learning curve, and there's way more than you need. Conversely, if you go inside with some enterprises, when you hear people say things like, we didn't like the offerings that were out there, so we built it ourselves, that is a very common red flag I have heard and seen in industry. But if you are doing something simple, your needs are relatively straightforward, and you just need something to take care of a particular part of workflows you're doing or how your business operates, now it's very, very easy to quickly put together internal tools that you code, yourself, like 100%, just for that need you have. And then also, if they're not very good or they have problems, again, in the spirit of the throwaway prototyping, you can iterate and take the learnings you had from doing that and build something better, right? And this doesn't have all the time and effort sink that traditional kind of monolithic software development, would have. And on that note, as I'm sure people have probably thought of as we were discussing this, this whole approach is much more aligned to agile software development practices. I know there's a lot of kind of credo around agile, and it's been overused and used and abused as almost a cliche now, in that some organizations do it well and some organizations do it poorly. But obviously, this iterative prototyping, throwaway prototyping is much more in alignment with doing iterative agile development principles than doing something in a waterfall way. So that's something to bear in mind as well. But if you're already doing agile development, then making the case for doing this type of prototype, throwaway prototyping is probably easier to make. Okay, so that is pretty much it. I will talk a little bit about the company and what we've been up to and how we can help. Now, I typically say that at Praktikai, we do three main things. We do business intelligence, we do artificial intelligence, and we do strategic intelligence. So some of what we do is helping businesses understand their data, a lot of reporting, a lot of visualization, primarily in Power BI. We also, as we have talked about in this presentation, do a lot of automation and building product using traditional machine learning, and then also obviously generative AI technologies that are all the rage right now. And that's kind of the second piece, the artificial intelligence piece. And I hope also from attending this webinar, you can see that as well as building using these tools, we also, as they say, eat our own dog food and are adopting these tools internally to make our work better and faster and allow us to be more productive as a very small team. And then the strategic intelligence piece is kind of the bottom two. We provide strategic guidance to folks at the leadership level about how to actually, do AI and make a roadmap and a plan for the future about how to integrate that into your organization and future-proof your business, large or small. And then part of the strategic intelligence as well is just educating people in an organization, whether they be, folks that are executing the work on a tactical level, or whether they're people driving the whole organization at a strategic level, and just educating leadership about AI and data and what that should look like and how to be, prepared, because things are moving so quickly. All right. So that will pretty much conclude it for the content. I hope you enjoy the webinar and that you learned something. If you want to learn more about what we're doing at Praktikai, you can check us out at praktikai.com. You can also reach out via email to contact@Praktikai, and we are on LinkedIn as a company under the same. All right, so happy to connect with you or have you follow what we're doing further. And that will pretty much do it. And so now I will turn things over to questions, and we have a little time left for sort of open discussion. So thank you for attending the webinar. I'm going to stop the recording now, and we can adjourn to Q&A.